Okay, I'm making this video to discuss the acidic properties of carboxylic acids, and a practice problem here asks for what the correct products would be to demonstrate the acid properties of carboxylic acids. So I would like to do a walkthrough and talk a little bit about those acid properties and also identify the acid, the base, the conjugate acid, and the conjugate base of this reaction, and discuss a little bit about what the significance of those things are. So, carboxylic acids are proton donors. A proton is also known as a hydrogen ion. So, they are generally weak acids, which means that only when you put them in water, only a small portion of them actually dissociate into carboxylate anion and hydronium. So by definition, because it's a weak acid, only a small percentage of them actually dissociate. So I'm going to walk through how to work through what the answer to this problem would be. So we're looking at a 2-carbon carboxylic acid, which would be ethanoic acid. This is also the common name for this is acetic acid, which is also the main component in vinegar. So we want to look at the acid properties of acetic acid. I'm going to start this slideshow and give myself, I thought I was going to give myself a blank screen, but I don't need to because I can write it right there. Booyah. Okay, I need to activate my pen. Activating my pen. And I'm going to have it be a nice blue color. Good, good. So I'm going to draw the structure for the acetic acid, which is the common name for ethanoic acid. So we have CH3. Oh goodness, will it erase? I feel like that was a mess. All right, CH3C. This is the carbonyl group, and together with an end carbon and a hydroxy group, this is what makes it the carboxylic acid. So we're going to add this ethanoic acid or acetic acid to water. And again, this is in equilibrium. An equilibrium will be produced in which a small amount of this dissociates. And this is the hydrogen right here that's going to get donated. So an acid is a proton donor, so this hydrogen is going to get added to the water, which makes this the proton acceptor. The proton donor is the acid. The proton acceptor is the base. So in this case, water is acting as a base. When this hydrogen gets donated to the water, we get a hydronium ion, which is H3O with a plus, and we get what's called a carboxylate ion. So the carboxylate ion is going to be everything that gets left behind, and it carries a negative charge. So we have CH3, C, still have our carbonyl group, which is a carbon double bonded to the oxygen, and then this carries on. This carries a negative charge, so this whole thing is called a carboxylate ion. Now, to identify the conjugate acid and the conjugate base, to come up with conjugate acid-base pairs, remember that conjugate acid-base pairs differ by 1 proton. And a proton is a hydrogen ion. Okay, and the acid is always going to be wherever the hydrogen first of all, where the hydrogen starts, and then the acid is going to be where that hydrogen ends up. So here is where the hydrogen ends up with this hydronium ion. Remember that H3O, hydronium, H3O ion is H3O with a plus is hydronium ion. That makes this the conjugate acid, and that makes this the conjugate base. So this carboxylate ion is always going to be the conjugate base of a carboxylic acid. So this, let me change my color. This would be a conjugate acid base pair, and you can see it's differing by a proton. There's an extra hydrogen here. And then these two here would be a conjugate acid base pair. This one has the hydrogen and this one does not. Now the significance of this is this carboxylate ion can be involved with reactions that are important to life, and for example, one of them is with the production of soap. When you produce soap, you start with oils, fats and oils, which are made of these fatty acids, carboxylic acids, and in the process of making soap you do produce this carboxylate ion, which becomes the active soap portion, the active part of a soap molecule that does the cleaning. This can also produce, it can be bonded to ions such as sodium or potassium and produce what's called a carboxylate salt. And in my next video, or in another video, I'm going to show the reaction of a carboxylic acid with a base and show you the significance of this reacting with a sodium to form a carboxylate salt, and why, how the properties of it change after that has happened. So in review, a carboxylic acid is an acid because it's a proton donor. The proton is being donated to water, so in showing the acid properties of carboxylic acids, we want to see the donation of the hydrogen to water to produce the hydronium ion. It is the hydronium ion that increases or decreases the pH of a substance, so making it more acidic. One of the other products in this dissociation is called a carboxylate ion, which is a common ion within the biochemistry world. So that's all I have for this one. Thanks for watching. Okay, I lied. I'm back. I wanted to bring the end of this video back to the original problem, in which it asks for what the correct products would be in the equation shown below. So when we add a carboxylic acid to water, this hydrogen gets donated to the water to produce hydronium. Now if we look at the choices here, only one of these choices, answer B, has that hydronium ion. One thing that is different about the way this is represented, and you have to be careful and really think those things through, is that in this the OH group is written upwards, and that carbonyl group, or the double bonded carbon to the oxygen, is written sideways. So it really is the same thing, it's just written a little bit differently. When you look at the carboxylate ion here in B, you see that the negative sign is up where the hydrogen was lost, and we have the hydronium. So over here, that hydroxide was, or that hydroxyl group was written down low, and you see that O there. So just another way to represent the same thing. So the answer for this is B. When you are demonstrating the acid properties of a carboxylic acid, you will see the hydrogen ion, that proton, being donated to water to get hydronium and a carboxylate ion. So this is the end for real. Thanks for watching.